Hey guys, so we'll be talking about likelihood ratios today, and this is like a topic that comes back a few times, well, just ABM as a whole. And if this has come up in the paper, it usually is like quite a few questions. So once you've got this down pat, you're pretty much good to go. So a likelihood ratio is essentially a property of a test that you do to determine whether it's likely or unlikely that a patient will have like a particular condition. So in terms of likelihood ratios, each test will have a positive likelihood ratio and a negative likelihood ratio, and they're used in different contexts. A positive likelihood ratio is when you want to rule something in. So you want to do this test, have it come back positive, and use this to determine how much more likely is it that this person has this thing that I suspect, given that this particular test has come back positive. A negative likelihood ratio is used when you want to rule something out. So you do the test, it's come back negative, and you're thinking, how much less likely is it now that this person has this condition, given that the negative likelihood ratio test, given that the test has come back negative. So in terms of actually calculating these two numbers, they're pretty much just based on sensitivity and specificity, which you should sort of remember from first year as being like properties of like the test itself. And the things that don't change with like the population, that don't change with the person that you're doing it on. They're literally just properties of the test. Okay, so just a little bit of revision. Sensitivity is your true positives over everyone that has a condition. Your specificity is the true negatives over everyone that does not have the condition. So if you want to think about like this equation here, where positive likelihood ratio is sensitivity divided by 1 minus specificity, you can sort of think of it as the probability of a positive test in a person that has the disease over 1 minus specificity, which is equal to the probability of a positive test in a person that does not have the disease. And then you want to rule something out with the negative likelihood ratio, which is given by 1 minus sensitivity, which is otherwise known as the probability of a negative test in a person with a disease over specificity, which is the probability of a negative test in a person without the disease. So it'd be good to just kind of commit these to memory. And it's sort of like, if you think about it too much, then it doesn't make sense. But if you think about it just a little bit, it makes enough sense for you to remember it. Okay, so you're going to be thinking about the likelihood ratio and thinking about the size of this actual number. So anything close to 1 is not particularly helpful. Your denominator and denominator are super close. And it just doesn't really provide you much information once you've done it, because even if it comes back positive, even comes back negative, you're like, okay, that really hasn't changed how likely this thing is going to happen just because like your denominator and denominator are so close. So in terms of actually using your likelihood ratio to determine your post-test probability, you want to use this thing called a nomogram, which is how we convert these pre-test probabilities to post-test probabilities, taking into account the likelihood ratios of the test that you're doing. So all of your pre-test probabilities are on this side of the graph, and all of your post-test probabilities on this side. So you might be thinking, what is the pretest and how do you find it? Like, how do you just know how probable something is for for a condition? So pretest probabilities are sort of like estimates based on like how common this condition is in the population, or like out of everyone that has like shortness of breath, how common is like a pulmonary embolus? So it's more of like a approximation kind of thing. You don't have to know exactly for this one particular patient, given all of these things, how probable is it that they have like a pulmonary embolus? It's more of like a general in the population, what's like the general likelihood of it happening. So your likelihood ratio, of course, is this number here. So let's just give some random example. Let's say the pretest probability you figured out to be 20. You've calculated the likelihood ratio. You're trying to rule in a condition. So you look at the positive likelihood ratio. And let's say that's been given to be 10. So you just draw another line here. You draw a line connecting the two dots, and then you keep going. And that essentially just gives you the post-test probability, which was like 70, 75, let's say. So just in doing this, you, with your positive likelihood ratio test, and that's come back positive, you're more confident, you're much more confident now that this person has this condition. So it's gone from 20% confidence to like 75. So you want to think about the size of the positive likelihood ratio. If you have two tests that you could choose between and one had a bigger likelihood ratio, then it sort of is not necessarily better in like a more general sense because you've got cost and all that's taken into consideration, but it's better in terms of if this new test would have come back positive, you'd be even more confident that this person had the condition. So as an example, if you had this like huge likelihood ratio of like 100, and again, you're studying at the pretest probability of 20, if you draw a line up all the way up, you end up with this absolutely huge post-test probability, which means that you're like almost certain, given that this like particular test has come back positive, that this person has this condition. So you want to think about the likelihood, negative likelihood ratio as well. So given that your test has come back negative, how much less likely is it for this person to have this condition? So you want to rule out conditions. So let's say you've got a 0.2 negative likelihood ratio, then you draw that line down and then continue it. So instead of being 20% probability, it's now at like whatever numbers between that, like a 3, let's say 3%. So you're pretty sure, given that this test has come back negative, this person doesn't have this thing. And this table here that they like to show in the slides is just like a ballpark figure of how likelihood ratio size corresponds to a change in your probability. So anything that's really small means you've got a decrease in probability. So it's less likely this person has this thing because this test has come back negative. And then your likelihood ratios that are bigger means that you get an increase in probability. So given the test has come back positive, you're now more sure that this person has this thing. Okay, so with absolutely anything, it really, really helps to work through an example. And so we've got one here for you to work through. We'll work through it together. And this is sort of how they usually like to present the questions. This is just like a little like paragraph, and you have to like draw out information yourself and make your own like sensitivity specificity table. So in tackling this, the first thing I would really like to do is to put this into like a table, because I cannot think otherwise. So we'll have like the has cancer as a column, doesn't have cancer. And this is the gold standard test. So then you want to use your new test. Test has come back positive. Test has come back negative. So you look at this, 200 patients are enrolled in the study. We don't really need to use that information. 100 patients are diagnosed with bowel cancer by the current gold standard test. So everyone under this column, it would be 100. The new test diagnosed 80 of these patients with bowel cancer. So you can put 80 here, but also diagnosed 5 patients that don't have bowel cancer with bowel cancer. So they don't actually have cancer, but they've been diagnosed by the test as having cancer. So we pop it here. So we can pretty much just fill in the rest of the boxes. If 100 people have cancer, then 100 people don't have cancer, because it adds up to 200. And then the people that were detected negative by the test that don't actually have cancer is 95. Okay, so now that we've put this table together, let's put some lines in so it's less confusing. Oh, that's really ugly. Okay, that's fine. It is what it is. We can figure out the sensitivity, which is equal to 80 over 100. And then the specificity, which is equal to 95 over 100. And remembering the equation for a positive likelihood ratio, which is sensitivity divided by 1 minus specificity, which is equal to 80 over 100 divided by 5 over 100, just skipping that step of 1 minus 95 over 100, which gives us 80 over 5, which equals 16. So our positive likelihood ratio is 16. Yay, we've done this. Oh, that shouldn't be a plus, that's just 16. Okay, cool. All right, so the question continues. We've got persistent change in bowel habit. And given that the prevalence of bowel cancer in individuals with this particular symptom is 30%, we're trying to calculate how likely he is to have bowel cancer, given that this new cancer test has come back positive. So this is asking us to calculate the post-test probability, given that we know the pre-test and the likelihood ratio. So they've pretty much told us what the pre-test probability is. It's 30. And our likelihood ratio from before would be 16. So let's pop it somewhere around there. This is not very accurate. Use a ruler in the exam. So then all we want to do is join up this line. Whoop, all the way up. All right, so that gives us like an 85%. So that essentially is our post-test probability. Because this test has come back positive and our likelihood ratio is like a pretty big number. Once we've done this test has allowed us to become 85% like certain that it's just 85% likelihood that he has this thing. Yeah, that's pretty much it for likelihood ratios. So if you do see any exam questions, definitely work through them and like try to understand it, or just be able to apply the equations and you'll be set. Thanks for listening.